All right, we're doing multiplying and dividing rational expressions. And once again, I'm going to keep saying this until we get it. Rational expressions, it's fancy for expressions that contain fractions. And this entire chapter is on fractions. So here we are. This makes us smile. We have our corn down here making it feel like fall and Thanksgiving on the way. And we have a very easy problem in front of us that maybe reminds us of the good old elementary school days. Nice small numbers where we sing and dance in the morning and everything's good. But 2/3 times 3/9, we still factor, except we didn't call it factoring. We called it cross-canceling. So look what we did. We took this 9 and we had a couple of factors. We could have chosen 3 times 3. We could have chosen 9 times 1. But when we choose 3 times 3, that enables us to cross-cancel. And now we can multiply and get 6/5. And that's always what we do with fractions. We always try and simplify them before we work with them. So of course today we're going to have fractions, but they're going to be algebraic rational expressions. So step 1 is always factor. Anytime we're in algebra, we always try and factor to make our life easy. So I'm going to start off with the bottom actually here, because I see right away I can pull out a 5. This signifies to me that I should be looking for either a 5 or a b plus 3 so that I can cancel them. And immediately my eye is taken to b squared minus 9, because I know b squared minus 9, it has a factor of b minus 3 and another factor of b plus 3. So I can see my cancellation happening there. I'm not quite sure what I'm looking for with the next two, but I do know that 3b squared plus 9b I can factor into one being 3b and the other factor being 3b plus 3. Oh, okay, so now this 12b squared, I'm going to go back over there and I'm going to factor that into 3b times 4b. Now notice with 12b squared, I had a lot of factors. I could have chosen 6 times 2b squared. I could have chosen 6b times 2b. I mean, there's a lot. But I kind of factored everybody else to see what I'm going to have to force 12b squared into factoring. Now, the b plus 3's cancel out. I can cancel any numerator with any denominator. Cancel any numerator with any denominator. When you multiply or divide. Not when you add or subtract, and that's tomorrow's lesson. So now I can cancel the 3b and the 3b, and I have a factor of 4b left over, but nowhere is there a 4b to cancel. Same like here, I have a b minus 3, I have a 3b plus 3. I don't see any more factors the same. So my final answer is b minus 3, and 5, 3b plus 3. Let's get this thing out of here. And that's it. All right, example number 2. We again have a multiplication problem. So I'm going to do my steps. Step 1, I'm going to factor. Factor, factor, factor. Okay, first one I can pull out a greatest common factor. Again, I'm going to hold off on the 6a. I want to see what else presents itself in the problem. And I'm going to hold off on the 3a squared. And down here I'm going to pull out an a. And I'm left with the factors of a plus 2. Now I'm seeing here I got a factor monomial of 2 and a factor monomial of a. So this 6a here, I'm going to break down into 3 times 2 times a. And this 3a squared, I'm going to break down into 3 times a times a. Now I know I can do that because this is a monomial of 2, and now I created another monomial of 2, and they can cancel out. And now I created a monomial of 3, which can cancel out with this monomial of 3. And I created lots of monomials of a. One on the bottom can cancel out with the one on the top. And another one on the bottom can cancel out with the last one on the top. And the a plus 2 and the a plus 2 cancel. So when everything is canceling out, I really get 1 as an answer. And if you had not canceled up here, if I had done quick distribution, multiplied that out, you could see I would have gotten 6a cubed plus 12a squared over 6a cubed plus 12a squared. And anything divided by itself is 1. All right, and the last thing is we have to look at, it's a little bit of division. But this is easy because you convert division to multiplication. Let's get this pulled out so you can actually read it. So what we're going to do, and there's been a lot of little chants I've heard over the year. I've heard keep, change, flip as ways to remember how to do division. So we keep the first number. We change the division to multiplication. And we take the reciprocal of the second term. Now, nobody's ever told you why that is. We take division, we change it to multiplication. Why didn't we change it to subtraction? Why? Well, I'm going to actually show you that in a few days. So right now we just want to get the hang of taking fractions and reducing them by factoring. Okay, so I'm going to look at this and I'm going to factor now the x minus 2. My step of factoring. My x minus 2 doesn't factor. I'm going to leave my monomial. I always leave that till last. Here's another monomial. I'm going to leave that till last. And now I'm going to take the 4 as the greatest common factor, x minus 2. Well, I created a monomial of 4, and 9 doesn't cancel with 4, but the 9 and the 3x. If I factor 9 into 3 times 3, and I factor 3x into 3 times x, I've created nice monomial cancellations. This is a binomial, so a binomial may cancel with a binomial. I'm left with no other cancellations. I have a 3 left on top and a 4x left on bottom. Okay, and the last one, example number 4. Oh boy, I gave you a division and a multiplication. So first thing we're going to do is rewrite this. 3b squared, I'm actually going to write out as 3b times 3b. There, I factored that. Division changes to multiplication. I flip. So the 3b goes on the bottom and the b plus 2 goes on the top. And I don't flip the second fraction because I only flip the fraction that comes right after the division sign. It doesn't mean flip everybody. It says flip what you're dividing by. I'm dividing by 3b over b plus 2. That's why that got flipped. So this will be 2b plus 2 and a b on the bottom. And I look to see what I can cancel. Well, this 3b didn't even have to factor because I see it can monomial cancel with that 3b. But this 3b can factor down into 3 times b, and then I notice that this b can cancel with this b. And I'm left with a 3 on the top, a b plus 2, a 2, and a b plus 2. And nothing on the bottom, actually a 1 on the bottom, but I don't really like to write that. So if I clean this up, 3 times 2 is 6. And then I can write b plus 2, and I can write squared because I have 2 of them. So that would be my final answer.